Day 149, Surface Water and Groundwater. Our purpose today is to learn more details about the water cycle. The biggest part will be how part of the water cycle is water moving downward through the ground. Relevance: many farms and most of our towns rely on groundwater. Success: you will measure how water flows through materials and compare answers with your classmates. Today's grades: you'll have a project grade and you'll have a homework grade. Our next quiz is in 3 or 4 days. Part 1, review the water cycle. I assume that you have learned a lot about this in previous science classes. The most simplistic cycle that's taught to students in elementary school is that we have a body of water and it evaporates into the invisible water vapor into the air, and when it cools it will condense to be visible little droplets that float in the air, making clouds and whatnot. And then when those droplets get big enough, colliding together and sticking, then precipitation happens in the form of rain, snow, sleet, hail, that kind of stuff, and it falls back down into the collection of water, whether it be an ocean or a lake or a river or just simply wet ground. So this is the most simplified version of the water cycle. We looked at evaporation, condensation, and precipitation in parts earlier this semester with the weather units. So we've covered that in one way or the other in the past. We haven't really looked at this collection part too much. We've talked about oceans and rivers. Let's talk about other things. First of all, seas are basically just small sections of the ocean. So seas or oceans have salty water, and everything else that we can drink would be called fresh water. Lakes. That's a large body where light does not reach the bottom. Big enough for waves to prevent plants from growing at the edges. Smaller bodies are called ponds. There's no great firm difference between lake and pond that everybody agrees upon. It's sort of like the difference between what is a very large hill and what is a small mountain. It all depends on the person who is looking at it. There is no specific height that a hill has to get before it's called a mountain. Let's see here. Wetlands are something that you will hear about in the news. That is an area covered by water for at least part of the year. Animals often find good living spaces in these areas. There are lots of laws about keeping wetlands natural. It's difficult to build on wetlands because of these laws. And so you'll see this topic brought up in the news once in a while when somebody wants to develop a wetland, or when people want to pass new laws to have stricter controls, stricter protections on wetlands. Next page. Bog. We have a bog close by to Fox Lake. You may have visited as a middle schooler, called Volo Bog. It is south of town on Highway 12. Okay, that's a swampy area that only gets water from rain and snow. It has mild acid in the soils, not much oxygen, and lots of decaying plant material. The soil is spongy, lots of moss and grass grows there. So this is kind of a distinctive environment with this bog, and so that's why it deserves its own name and park designations. Here's a more complete version of the water cycle. Now, this is very, very basic. This is much more complete. Okay, so we have the clouds, and we can have the precipitation. Evaporation to the clouds and back to precipitation. This is what we saw a moment ago. But this is assuming that the precipitation falls back directly on the source of the water. Winds will blow the clouds into other areas, and it can fall in different places. It can fall way up high in the mountains as ice and snow, and there it stays for a long time before it melts again. Or it can fall as rain, and it can either run off. Now that means the liquid is at the surface the whole time, and you can visibly see little drips moving across the ground, little streams and whatnot. And then it flows into a lake or a stream or something like that. But this runoff could also soak into the ground, which we call infiltration. Water from the lake also goes down into the ground with this process called infiltration. As it goes into the ground, it can slowly move downhill, even though it is still underground, and we call that subsurface flow. That is just under the ground level. Way down deep in the cracks of the rocks, we can say groundwater flow. A little bit different than subsurface. This is the deeper version. And notice how this is flowing downhill, so to speak, even though it is still underground. Or it can remain in a stationary position, and so we call that groundwater storage. Now, all this water that's flowing, whether it be runoff or the flow underground, does not necessarily end up in the ocean. Some of it gets sucked up by the plants, and from the plants it evaporates. We call that evapotranspiration, fancy word. Or it can evaporate from the lakes and rivers that it collects in. Alright, so notice that some of the water goes into the ground during the water cycle. Some of it stays at the surface. The percent of the water that goes into the ground is partly due to the type of soil in the area. Different soils have different permeabilities. This means they have different abilities to let water flow through them. Some soil lets water go through very, very quickly. Some soils don't let water through it at all. So we're going to see this video here next, and then we're going to do a project which is to measure the relative permeabilities of different soils.